Well, hey there, gang. Most of you will remember this guitar from a couple of weeks ago. This is the Timberline Kevin Hall luthier built guitar from the 70s. We did the big long side crack repair on that. I still haven't buffed that lacquer, by the way. In general, it's best to let that sit as long as you possibly can before you level sand it and buff it out, because lacquer continues to shrink for a very long time after it's been sprayed. So I'm just letting that cure up because I've got other work to do on this. Namely, it's time for a neck reset. It's a 40-year-old guitar, pretty typical thing. The bridge is at full height, but the saddle has been cut down to basically nothing. It's maybe a 32nd of an inch exposure at the most, so that's not coming down any further. And the action is getting a little bit tall. I need to measure the string action as part of the computations for figuring out how much of the heel I need to remove. But before I measure that, this thing has actually had a replacement nut put in at some point. On the bass side it's pretty good, but on the treble it's quite stiff. I was noticing when I was strumming this thing for a little bit, testing it out. So I'm going to take a few swipes with the file to bring this down more in line with what I consider normal, and that way I can get a better idea of what the action really is. There are people who like to measure the action with a capo on at the first fret. I tend to measure it without that because I figure that unless you play with a capo, it's better to have it set up the way that it's going to be during regular working conditions. So we're looking at about 9/64ths on the bass and over 7 on the treble. There's not a tremendous amount of relief in this neck. It's about 6/1000ths, which is actually pretty much Martin's spec for new guitars. The other thing is there's no truss rod in this guitar, which will have certain people aghast, but you have to remember in 1979 you couldn't buy a Martin with an adjustable truss rod. At that point they had those square tubes. Previous to that it would have been a T-shaped thing. But, you know, the neck's pretty good and straight, and it's probably got some kind of reinforcement in it, so it's doing pretty well for itself. One thing to take note of here, remember how I mentioned that the nuts seem to be misaligned, that it's hanging over the bass side? Well, if you look at that treble E, the string spacing away from the edge of the fingerboard is pretty typical here. It's about 3 millimeters, an eighth of an inch. But as we move upwards, that gap gets narrower and narrower, till at the top end we're barely 1 millimeter away from the edge. And it's the opposite on the bass side. It's wide here, narrow at the nut. That means that the center line of this neck does not match that of the body. It's possible it was made that way, but what can also happen, especially in guitars that have a deep cutaway like this, is that over time string tension can actually pull the neck downwards. If you think about it, the upper bout of a guitar is arched and it's a pretty strong shape. It's kind of an egg shape, just naturally strong. If you remove the support on one side, the neck just kind of gravitates towards that direction. So it's something we can look at when we're doing the neck reset. We can compensate for that and bring that center line back this way to align more perfectly with the body. I put a nasty old set of strings on this guitar because I wanted to check out the relationship between the neck and the front edge of the bridge here with this steel ruler held on the top surface of the frets. I can measure the gap between the soundboard and the underside of that ruler. I did that with the string tension off, now I'm doing with it on. And in this case I see that we end up with something around 5/32 of an inch. The increments aren't important, this is about concepts more than actual figures. Previously it was 3/16 of an inch. So that means that there's about a 32nd of an inch dip in this soundboard under tension in front of the bridge here as the string tension rolls it forward. That's important because in a neck reset, ordinarily, we'd want to project that steel ruler up to a point where it's about level with or maybe just slightly above the top surface of the bridge. I have to take into account that sinking because that's actually removing material from the eventual saddle height. And if I want a good tall saddle, I need to figure in that string tension and add about a 32nd of an inch to the total set of the neck to account for that. Here's another indication that the neck reset is just about due. You see the end wrap windings on this low E string here. They've migrated up and over top of the saddle. So it still sounds okay, but it's eating up a certain amount of the compensation. It's effectively shortening the string length. And in some cases this causes really kind of funny, muffled tones. So with a taller saddle, this should not be as much of a problem. Another little aside for those of you who are interested in designing your own guitar. In this case, you can see that the saddle slot has been moved back from the front edge of the bridge relative to a Martin bridge of similar proportions. And there are a number of reasons why you might want to consider trying that. It gives you greater area and extra material up front here to spread the load of the string tension. And it pushes the pivot point closer to the center line of the bridge. Over time, that might decrease the amount of deforming that goes on in the soundboard. Also, depending on your placement of the bridge pins, it can give you greater downward pressure on the saddle, increasing the volume, which is a very attractive proposition. However, at the same time, moving the pivot point backwards, you might actually be putting less energy into the top by limiting that forward rocking motion of the bridge, thereby reducing the volume. So you can see it's an infuriating game of little tiny pluses and minuses. It's microscopic stuff. As a repair guy, having the saddle close to the pins is attractive to me because you can get away with having less saddle exposed. That's why you often see me cutting string ramps in those old guitars. Trying to get more downward pressure and keeping the strings from flopping around on the top of the saddle causes a weird buzz like a sitar. And having this little saddle exposed might not have been possible in this guitar with a standard bridge. Rather than 40 years till the neck reset, it might have been 30. And again, the narrow distance also causes this string wrap phenomenon, so it's like a cascade of outcomes. My teacher, David Freeman, used to call these things bottle of wine discussions, because you go on and on all night long, the bottle's gone, you still haven't come to the answer. And the main thing to keep in mind is, after one little decision like this, the flowchart of ramifications, both pro and con, just becomes immense. You can't figure it out in its entirety without infinite experimentation on a million guitars. It's like being 5 moves into a chess game. The possibilities are endless. So it's time to take the neck off this thing, and you guys are going to be party to some really bleeding edge luthery technology. So much so that I had kind of reservations about showing you this, mostly because I'm aware that I have a pretty big audience here, and this is going to be the first time a lot of people are going to be exposed to this technique. And I don't really feel like it's my concept to disseminate. Like, I did not come up with this, and I want to make sure all the credit goes, in the right direction. This is all Ian Davlin's work with input from Frank Ford. Frank Ford is legendary in the guitar business. I think Ian has to wait another 10 years or so before we can officially bestow that title on him, because it's a whole big thing. You got to get all the luthiers together. We need to rent a hall, and someone has to make a plaque. If you follow the Stuart McDonald channel, you've probably seen Ian working with Dan to do some Finnish touch-up workshops. He's great at hiding the boo-boos, but he's also one of the key minds behind the heat stick. And I like the heat stick. Steaming a neck works fine like 90% of the time, but when it doesn't work, it can go terribly bad really, really quickly. The misdirected steam can cause great big white blush marks and old lacquer. And this thing, I'm pretty sure, has a French polish top, so that's even more susceptible to moisture. Other times you get, steam shooting out of places that you weren't expecting, and they can cause pools of condensation. Then you've got staining and witness lines and stuff. So, it's good until it's not. Dry heat is nice, or drier, because you almost always have to put a little water in the joint as well, especially if you're working with hide glue. The downsides to the heat stick involve the size of the heating element. I think it's got to be 1/8 of an inch to be able to take it to market. You'll notice that StewMac supplies an even larger drill bit to go with it, because they don't know what kind of ham-fisted ogre is going to buy one of these things and try to jam it into a neck block at full speed. Like, just what happens if you try and do the same thing with a 1/16 of an inch bit? Go 3 inches deep and then break it off. Like, maybe it crosses the boundary between the tenon and the neck block. You've nailed the two pieces together irretrievably. So that's the kind of thing that retailers have to think about. It leaves a big hole. The other thing is, unless you've got 2 of them going at the same time, you're probably pulling this thing out and going back and forth from side to side in 2 big holes. Maybe you drip a little water in, get one side hot, then try to catch up on the other. So it'd be nice to be able to do 2 at once. On a dark ebony board like this, I can make those big holes disappear, it's no problem. But on some of the lighter woods, it's not always so easy. And strange as it may seem, there are these oddball collector types out there who just can't stomach the idea of seeing any evidence at all of a neck reset. They get offended by seeing that little tiny half moon of material on either side of the fret. Ian brought these issues up with Frank. Frank went searching for parts that could miniaturize the process, and together they came up with this. This is a stainless steel tube. It's only a 1/16 of an inch in diameter, 1.5 millimeters-ish. And inside that, there is a nichrome, a nickel chromium alloy wire, encased in a heat-resistant insulation. And we're going to heat this thing up using electrical resistance. Now, there are parts of this operation I'm going to show you, but there are a few other little construction fine points that I'm not going to discuss because this involves making a sketchy-looking electrical device in your basement, possibly for use with water, and I don't know your level of shop acumen. I think Ian feels the same way, kind of. Like, you want to be able to vet someone before laying this on them. It's not like I can stand next to you and make sure you know what you're doing and say, hey, buddy, you trying to electrocute yourself? I didn't discuss how to do this with Ian. I told him I was making this video. He's fine with it. But, I learned this by looking at a picture on his Instagram feed and another one on his website where he was kind enough to leave a parts list. And that's how I know. I mean, I figured it out by looking at those photos. If you don't have the knowledge or skills to see what I'm doing here and kind of put it together for yourself in your head, then you're probably not ready to go about making this. I'm going to leave a link to Ian's YouTube in the description. It's Ian Hates Guitars. It's the same as his Instagram. But if you really want to make one of these and you feel you need more information, I'd suggest signing up for his Patreon. He's got a couple of tiers there. And you should expect to pay him for a consultation fee if you need more info. Plus, I mean, he's just posting really good tips on there. And again, this is all for people in the trade with some experience who actually do neck resets. This is not a hobbyist procedure. I mean, the materials outlay alone is going to preclude you from doing it if you're just, someone who's got to do it for one guitar. You're better off finding someone else who can actually set necks for you. I'm going to start by removing the 15th fret, and I'm just very lightly scoring along each side of it here. This is very superficial. What it does is it kind of prevents any chips or tear out from running past the edge of the fret and into the exposed surface of the board when it comes time to pull them up. It's just very light. I managed to talk to Kevin Hall. We exchanged a couple of very nice emails, the maker of this guitar, and he says that he seems to remember that some of the early ones of this model he made with just a straight mortise and tenon joint. I'm not certain that's what this has, and I don't think he is either, so we're going to see. Maybe it's a dovetail, maybe it's a mortise and tenon. So regardless, I'm going to remove that 15th fret, get some heat on there. This old soldering iron has a notch ground into the tip so that it sort of rides over the crown of the fret and stays in position. You don't want to be dropping this off the board somewhere and onto the finish. There are some people who will actually run a bead of solder or solder along the fret as well to get some heat into it. Heating it up really helps if there's been, say, previous refretting done using glue. Just sort of softens things up a little bit. What can also help is putting a little water there as well. Just a little bit along each side. I have to concern myself with the connection between the heel and the body here. I don't know whether they were finished over together. I suspect not, but I do want to run a knife down this joint just to make sure that there's no finish that's adhering one to the other. The other thing is there's some weird divots and dents in the finish right adjacent to that joint. I don't know what those are about, but I can also see that this heel is made up of a stack lamination of pieces of mahogany, and there are a couple of little hairlines in between those, and also evidence of glue. There is the possibility that when I heat this thing up that I could be loosening those joints, and if it's a mortise and tenon, that's probably not going to be a big deal, but if it's a dovetail, there's always the possibility that you pull the neck free and you leave one or more of these segments stuck inside the pocket. I've seen that happen a number of times. So, you know, we just have to be careful. This is very, very thin and crispy finish in this area. I'll do the same at the heel cap. Okay, I just marked the center line here at the 14th fret. The question becomes, how wide? If it's the 1970s, are we going to make a mortise and tenon style joint to attach this? If it was a dovetail, we would expect the end of the dovetail to fall equal to or just slightly beyond the 15th fret here. But a mortise and tenon could be any width and practically any length. But we're going to assume it was sort of within reason. It's probably not a 1/2 inch tenon. It might be wider than that. The good thing is, by using these dry heat methods, we don't actually have to hit the glue line. The heat will radiate out from either the neck block or the tenon, whichever it happens to be sunk into, and transfer to the glue. I'm thinking it's probably 1.25 inches would be good, so like 32 millimeters. And so we're in here. So I'm going to drill through around these points. To do that, I've got this. This is an aircraft bit, which is very long, obviously very slender, so prone to breakage, and you have to be gentle with it. I'm going to start off by drilling backwards because there's less tendency for the wood to chip out around the start of the hole. And I'll mark a depth. We're going to go, probably down that far. And this would be a straight mortise and tenon, so I'm just going to go right up and down, I think. And yeah, I'm just going to drill some holes. Okay, we're plugged in and underway here. Apologies if I have to stop a number of times because of the fan going on with the power supply. It's pretty noisy. I've got the probes down in the neck. I've got positive and negative leads attached to those. I'm running these in parallel rather than series. And I've also got a temperature probe here that's hooked up to my multimeter, and I can use that to measure the temperature. Just above the fingerboard here, excuse me. I'm trying to keep it somewhere in the range of, you know, the sort of boiling point of water, somewhere, you know, 90 to 100 Celsius, 200 to 212 Fahrenheit. This is a slightly more gentle way of doing things than the steam. It'll take a little bit longer to get the whole mass of the neck block warm enough to get things sliding around. Let's see, this is running off of a DC power supply. That's important. It can't be AC. Like, you couldn't plug this into a rheostat or temperature control that we use for heating blankets and that kind of thing. It wouldn't function. Now, the nichrome is capable of reaching hotter temperatures, but you sort of run a risk. At a certain point, it starts to break down if it gets too hot. Like, the conductivity suffers, and eventually it's almost like it burns out, kind of like an electric range element, just stops working. So I'm kind of erring on the side of caution here. It'll take probably half an hour, 45 minutes to get things warm enough, but I can tell right now that the heel is actually getting quite warm, and I put my hand in here around the neck block. It's starting to warm up as well. I'm in my neck removal jig here, which you've seen in the past. I don't know whether it's a tenon or whether it's a dovetail. I thought I'd err on the side of caution and maybe put a little bit of pressure on it as it starts to go, just to see. The other thing I'm hoping the neck jig will let me do is keep the laminations for the heel all together in one piece. And if there are little fractures or cracks there, it's less likely to come apart, I think. At least I hope. After some time, I was able to insert my palette knife in between the end of the neck and the body there, suggesting that this was in fact a mortise and tenon rather than a dovetail, but the fit was very snug and it did not want to move. I worked it back and forth and got a little bit of wiggle in it. It seemed to be getting somewhere. I came to the conclusion that I might have a little bit better luck if I put some water directly on the glue joint. So I used my palette knife here as a depth gauge to figure out where the exact width of the tenon was, transferred that to the fingerboard, and re-drilled the holes about 1/8 of an inch closer. That allowed me to get some water in there. You can see I've actually upended the guitar because I want this water running down and out rather than inside if possible. Pushing up on the back of the heel with the screw was having absolutely no effect, so I was back to working it by hand, rocking it and trying to lever it out. At a certain point I could feel the one lamination give way, and I realized despite my best efforts it was going to come out in two pieces. Wow, that's tight. Okay, so it is a mortise and tenon. It was pretty accurate with the heat. I hit the glue line towards the end. It's so tightly fit. Good job, Kevin. Wow. That's so snug. Okay. Not the best thing that could have happened, but we can fix this. This is not too much of a problem. I'm going to immediately get this clamp back together before it even has a chance to cool off or even dry down, because at this point the glue is still sort of tacky, the previous glue, so it will accept this new tight bond that I'm going to put on there. Let's have a quick post-mortem and discuss what happened here and why, counterintuitive though it might be, mortise and tenon joints can actually be more difficult to remove than dovetails. How can that be, you say? They have similar glue area, but the dovetail locks together. Think of it this way. When a dovetail is seated in its pocket, it's got good contact on both sides. And the goal in removing it is to soften the glue using heat and or moisture. But when it comes time to separate it, all you got to do, really, is shift this thing upwards by about 1/8 of an inch, and then you're home free. You got space on both sides of the joint, it just comes right out. Now, that can be complicated by the accuracy and how it's cut. Some people, rather than a piston fit, will make it an interference fit and really drive them together, and if those two angles aren't perfectly matched, then there can be issues. On a mortise and tenon of similar length, though, what happens if I push up that 1/8 of an inch? Nothing. I've still got 3 inches of mechanical friction and glue to overcome. And these parts have been swollen by heat or moisture, so they're even more tight than normal. Trying to drag that through, like that glue is going to remain sticky. Even though it's soft, it's still got quite a lot of tack to it. How about pulling it out from the side? That seems to make more sense. On a tenon that's 7/8 of an inch long, that's still 8 times the distance and surface area I have to overcome and move through. And on a tightly fit joint, that's a lot. Practically speaking, the only way you can do that is by rocking it. And in this case, with a heel that's got an incipient separation in it, it's just too much. It's bound to come apart. In fact, you should count on this separation of the heel anytime you're trying to remove one that starts off with a crack in it. I saw that, I mentioned it to the owner, so he's prepared for this eventuality. And usually, it's going to go back together pretty cleanly. I like stacked heels. I think they're a responsible way to use a valuable resource. In my own work, before putting on the heel cap, I always sink a 1/4 inch dowel all the way through all the layers there. 2, if it's a Gibson style wide heel. Just added insurance for this eventuality. I'm going to reinforce this tenon that way too, in case it ever needs to come out again in the future, but I'll probably end up doing it back here in the actual tenon. So I cut a little landing, drilled a hole, put in the dowel, sawed that off, and then trimmed it flush. I scraped off the end of the fingerboard extension here because I'm going to be preparing a wedge that will fit under here to take up the additional angle from the neck reset. I'm cleaning up the edges of the tenon here, and then I'll scribe a line denoting the amount of material that has to come off the back end of the heel, transfer that along the side with a scalpel, and I'll pare down to the line using a great big chisel. This will get me sort of into the ballpark. After that, there's a certain amount of material that has to come off the inside surface of the heel so that it only contacts along the outside edges. That makes the sandpaper pull procedure quicker and easier. By pulling away from the heel like this, I'm correcting the angle relative to the body, but I can also shift the neck laterally by pulling out to one side or the other, and that's how I'm going to get a handle on this misalignment issue. I've marked the midpoint of the neck at the nut at the end of the fingerboard and also on the bridge here, and by holding a straight edge against all of those marks I can figure out where I'm going. This procedure is actually annoying. It's long and arduous and no fun. There's a certain amount of reshaping that needs to be done to the tenon, so I'm gluing on some veneer so I can recarve that. And here I'm working on the wedge that goes underneath the fingerboard extension. The saddle on this guitar is quite narrow. It's only about 2 millimeters wide, 80 thousandths of an inch. And the saddle slot is pretty shallow. Because we're going to be replacing this with a nice tall saddle, I want to make sure there's enough support underneath the surface of the bridge. So I'm going to reroute this for a more typical 3/32 saddle slot, the same size you would find in most Martins. At this point I can also shift that nut over so it's finally in alignment with the fingerboard. Okay, I think we're set to go. Saddle height turned out to be between 3/32 and 1/8 of an inch, which is pretty much what you want to see. The action is a much more manageable 5/64 on the bass, 4 on the treble. I've still got a little bit more finish touch-up to do over the next couple of days, but the fit is serviceable. And I spared you guys the agony that is watching someone correct the lateral alignment of a neck with a mortise and tenon. It involves removing material on one side of the heel to tip it over in the direction you want it to go. But when you do that, of course, the tenon on that neck also tips, so it no longer matches up with the nice straight and square pocket in the body. So I've got to add material on one side, remove a corresponding amount on the other side, back and forth a million times testing the fit until we finally get the two aligned and it's in the right place. Difficult to understand for you? Perhaps. Fun for me? Definitely. But at the end of the day you end up with strings that are in parallel with the edges of the fingerboard. And with the replaced fret, no holes are visible. Hooray!